Hello, everybody, and welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. And you look beat, man. What are you doing?
I am basically dead inside.
Well, I know that, but why today?
I'm just beat. Like we're doing condenser change outs, and I'm just exhausted. It's been a rough week.
You have your truck back?
Yeah. I got my broken down piece of crap back.
What was wrong?
I don't know. They claimed it was some what the hell was it? The sync module for like the lane changing that they reprogrammed, which I find it to be complete and utter BS. So it's probably gonna break down again.
Sweet.
I don't trust it anymore. This is like the fourth time it's broken down. So
Besides condenser changes this week, is that what you've been doing all week?
no, I've been on this Danfoss change out and pulling my hair out and then trying to clean up some of this Danfoss stuff and trying to deal with some of these issues like with this new controller that like DIs that just won't do anything.
Yeah, you were saying last time.
Like
Like no matter what you do with the programming, the inversions, wiring, it's just being dumb.
some controllers they work fine. The other controllers they don't.
Right.
Same components, same programming,
Same firmware?
same firmware.
Ridiculous. That's weird.
Yeah, I'm like at my wits end with it, just exhausted.
Yeah. Is that what you got going on the rest of the week? You're still doing condenser change out for the rest of the week? You said you had to wake up stupid early.
We gotta do 3 condensers tomorrow.
In one night?
One day we start early and we do them during the day. So
I don't even know what to say about that.
it's brutal.
I just noticed I had a pause thing. I can pause now?
What's that?
I just realized I can pause this. I can pause the recording.
Can you?
They must have did things because now I have a pause function.
Oh my god, that's so much better.
I have a restart function. So in case we're like, oh, that was crap, we got to re-record.
About time. I mean, they should have had it a long time ago.
Yeah, I agree.
All right, ready?
Yeah.
Just run around outside being unsupervised.
No, it's fine. You live in Indiana. It's fine. No, last week I was in Houston, and that was I was just trying to get as much stuff done as possible. We start training literally in I think 2 weeks. I decided to take 2 days off right before my birthday, and so I'm off tomorrow and Friday, and just so I can kind of recenter because I've been putting in a crap ton of hours just trying to get everything squared away. Is a really important thing for us because, well, for me anyway, we're doing the coolest like commercial curriculum, the VRF, the mini splits, the residential type units, the rooftops, just making sure everything is squared away before ice machines, making sure everything's just squared away and running before everything is cool. What else I got going on? Job fair. I got a job fair I got to go to. We're having one at Fullerton, California's training center, October 25th. So that should be fun.
I want a free swag bag.
They have swag bags. I think we're gonna have a couple Carhartt Coolest tool bags that they're giving away, and I think pretty sure we're giving away some tools. I don't know how that all works out, but I was just told that that's what we're doing, so that's what we're doing. So I'm flying out there in a couple weeks to do that, and I had realized today that I'm literally booked up every other week until May.
Yeah, I'm just wiped out and exhausted from that. Like I just looking, there's like condenser change outs to basically to the end of the year every week. It's just like not looking forward to it. It's like monotonous and I'm like beyond burnout from it.
Yeah, I get it.
It's just ugh.
Yeah, you were telling me about that. Yeah, so I don't know. Tonight we wanted to talk about some CO2 component stuff, component operation, basically talking about all the bells and whistles that are on a CO2 rack. And for the most part, like a lot of these things are kind of programmed the same. And because it's all compressor protection, it's all system protection, like a lot of the stuff that we're going to be talking about tonight, liquid injection, hot gas dump. And it all kind of circumvents around trying to make sure that we're maintaining the proper suction and discharge temperatures to make sure we don't grenade any compressors. So I guess we could start. You want to start about liquid injection? So I don't know. I could start. You can start. What do you want to do?
Liquid injection,
It's a prevention device.
straight Band-Aid.
Prevention device.
What didn't need liquid injection? 404. But no, so liquid injection. Why we need liquid injection? So we need liquid injection for a couple of reasons. So on the medium temp side, the transcritical side, we need liquid injection because we are running a large compression ratio. So it's
Wait,
going
wait, 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 what do you mean large compression ratio? How is that large? For medium temp?
how is 400 to 1500 not large? It's pretty large.
What's that?
That's a lot.
All right. While you're explaining, I'm gonna research right now.
It's
Go ahead.
still
Continue. Continue.
so we're running a larger compression ratio, so it's going to make more heat. You also have the injection of the low temp discharge into the medium temp. So you have that superheated gas coming from the low temp compressors dumping into the medium temp suction header. So at times, which is kind of rare, you still end up with high superheat. So you need some liquid injection to cool off the medium temp. So you need to reduce that superheat going back to the medium temp compressors.
So I just looked it up. I kind of ran the numbers real quick. So I assumed that we would do 1,500 pounds for the utmost max on the discharge on the gas cooler pressure, and I did 435 or
Nope.
420.
Nobody's
420.
even running 420. Most of the time they're running 390 to 400 because they're all jacked up.
All right. Well, even if it's lower than that, just hear me out, okay? Jerk. If I take 1550, because you have to add atmospheric pressure, which is 14.7 when you do this, so I just rounded up to 15. Essentially, it's only a 3.5 to 1 ratio, so that's not bad at all. That's what I mean. That's what makes systems so efficient, is the fact that you're running a lower compression ratio.
They're not efficient though. But
It's efficient if you're running a 3.5 to 1 compression ratio, where typically you're running 6 to 1, 8 to 1, and in R22 low temp you're running freaking almost 10 to 1.
yeah, which was a terrible refrigerant. I love how they always pick the terrible refrigerants that they compare it to. It's like comparing the Olympic runner to the guy with the one leg.
Those guys that have the mechanical legs can run pretty damn fast. I don't know if you've seen that before.
Yeah, well, I mean, kind of cheating. Like, yeah, they picked the worst low temp refrigerant they could pick, and or they're going to throw some 134A low temp on there to compare it. It's more efficient than this.
So anyway, so yes, it's to kind of make sure, because you got to remember we're pumping discharge gas directly into the suction of the medium temp. So we're trying to make sure we don't overheat the windings into that compressor. And as we run a higher pressure, that discharge temperature also starts to, delve up a little bit. So from what I've seen, typically they're trying to maintain on the medium temp, usually around 36. 36 seems to be the magic number as far as good superheat. And so, like, a lot of the programming, you'll see it's like 37 and a half. They'll cut out the liquid injection and they'll allow it to get up to about 55 degrees of superheat before they actually kick on the liquid injection. And like Kevin stated before, that's not the only reason why we do that. It's also to control the discharge temperature. So if the superheat is still good, they usually run this on a or function. So either if the superheat is high or if the discharge temperature is high, this would be the reason to do the liquid injection. And most racks, I've been going through a lot of programming here late, and it's been about 250 seems to be the cut in for the discharge temperature of the medium temp, and 240 for a cutout. Now, obviously, if you start having problems on this, it's, you can tune this to make it go a little bit lower, just to make sure you don't go outside of the parameters for anything. So if you were to set the discharge temperature lower, you'd have to make sure that it's not interfering with the amount of superheat going back to that compressor. But like I said before, you have that that little bit of a fail safe there because you're putting discharge gas directly in the butt end of that compressor.
It literally ends up hiding more things than it does anything else because most of the time when liquid injection's kicking in, you got blown valve plates or something else going on. It you can get away with not having it. Like for example, like there's Cardo doesn't put it on any of the racks besides the ones you guys did out there. And the only reason they even needed it is because it probably doesn't even need it anymore. It was just for pull down. But so I mean, you have so much flash tank load coming back like that. You struggle to even get superheat most of the time, especially when it's transcritical. You have the other problem. You have too little of superheat 90% of the time. Even with the low temp compressors clapping along and putting as much vapor in there and superheat as they are, it's still not enough. So most of the time, I hardly ever see liquid injection kick on. I've seen liquid injection kill more compressors than it's saved.
Hmm.
I mean, it's I think it's more of a band-aid than anything because it ends up hiding valve plates or bleed by or other issues.
Yeah, but that's another thing too. I mean, but you could use that as a gauge, right? Like if you see the history of the rack and you see the liquid injection not feeding as much as what it is, as much as what it was, and then all of a sudden then you have an increased liquid injection time on, then you could use it as a failsafe. One thing interesting, like I don't think I've ever seen alarms really set unless, I mean, you've obviously worked on way more transcritical than I have. Do they typically have, I mean, I know on the suction typically you have like the utmost lowest superheat setting on there to throw an alarm, but I mean, I'd expect a couple sensor controls that basically would tell you, hey, if this is running too low or too high or on, if the liquid injection is on for X amount of time, basically it'll say, hey, I have a problem.
I mean, it depends on the manufacturer. I mean, to be honest, like there needs to be pulse alarms for like different things for stuff pulsing, but then you end up with a bunch of nuisance alarms because I mean, let's be honest, when this thing's running transcritical, so it doesn't matter what manufacturer it is, like it
Mm.
still runs through a bunch of oil, it still has low superheat, like when it's running transcritical, I mean, so you start getting those nuisance alarms. So I mean, most of those racks struggle to keep 15 degrees of superheat when even with vape hot gas injection going, most of them struggle to keep 15 degrees of superheat, especially under a high flash tank load.
Yeah.
You look at it this way, like you're going to have a bunch of nuisance alarms for something you can't do anything about.
And you're talking about, so essentially when you're running where you have a very very big flash tank load, you have that vapor at the top there, but it's more of a saturated. I can't. Well, not that's probably not the right way to say it,
Vapor.
huh?
It's like a wet vapor.
Yeah, it's like a wet suction. Let's call it that. It's even on any diagrams that I've ever seen, it shows that like it's not straight vapor. They'll have like little chalk lines in there showing that you have a little bit of liquid in there as well.
Imagine it's raining. Like
Yeah,
well,
misting. It's misting.
it's misting. You're picking up liquid droplets and it's getting in there. And there's really nothing you could do about it. So like there's knockdown baffles. Me and Adam were talking about this from Westermeyer the one day. There is actually knockdown baffles that they could be ordering and installing in these flash tanks, which they should be. And that helps prevent the liquid carryover from that from happening.
Mhm.
But none of these manufacturers are buying these knockdown baffles. Like apparently it's a common thing in the industrial side where they're using more. Why do I always forget the name of the vessel? Not an accumulator. It's a
Thermosiphon.
th-
Thermal siphon.
not technically, but
Liquid vapor separator, like
yeah,
what you'd have on the pump liquid skid.
kind of like the Carnot racks have. It's a God. Why do I always intercooler?
Intercooler.
I don't understand why I forget. I every time, literally every time. But so it's like having an intercooler. The same thing. Like the intercoolers, most industrial stuff have knockdown baffles in them to keep the liquid in the bottom of the tank from getting sucked up in the top, where you would have your suction return gas at. Now that's what keeps it from becoming an issue.
Hmm.
Now those knockdown baffles would help with that. Obviously, it isn't going to completely solve the superheat issue, but I mean, it's It's an issue of you have that flash tank right there and it's picking up that cold liquid and there's nothing you can really do. Now that brings me to the next thing, the hot gas injection valve.
Hot gas dump. Hot gas dump.
So hot gas dump, there's a couple different ways to do this and it really depends on the manufacturer.
Hmm.
None of them seem to work well when it's transcritical. It just kind of is what it is.
Hmm.
So first and foremost, you have a solenoid that is dumping hot gas from the discharge of the
Hmm.
TC side into the medium temp suction. So
Hmm.
what it's doing is it's looking at a control. So it's looking at your suction return temp and your superheat. And when the superheat gets down, most of the time I see people putting it like 10 to 12 degrees and or 15 degrees. I raise them up to 20. So they inject more, but I want it to start injecting faster.
Well, I just had this discussion with James because I'm doing a whole bunch of questions on finishing up the CO2 presentation that we're doing, on that presentation, the class that we're doing at Coolsys, and basically I saw on one program for a certain customer, they have it set for 15 and 18. But then I saw another, I think it's the same manufacturer, just a different programmer or different customer, and they had it at 5 to 29. Yeah.
Yeah, that's an advancer. Those are advancer set points. Like,
No, but even the other one, the first one that it was an older advancer
so
rack that it was.
they raised it on the advancer racks. The problem is on the advancer racks, the solenoid orifices are way too small, and they don't flow enough hot gas. So it's like basically pissing down a hallway.
Hmm.
So you don't get enough heat coming off there
Hmm.
to really do anything.
Gotcha.
Then you throw a zero zone in there, and they got a solenoid big enough to turn the suction to 120 degrees, which I'd rather have that problem. I mean, and you could pulse the zero zone ones, and they work much better. But what you're doing is it's you're trying to keep that return gas temp from getting down too low and your superheat getting down too low. I mean, there's nothing you could basically do when you become transcritical because and you start getting that carryover because here's the problem. What happens when your suction temp drops? Your discharge temp drops. When
Hmm.
your discharge temp drops, the whole strategy becomes less effective. So as that suction temp tanks, you don't have the return temp or the discharge temps to help superheat that suction gas. So that's where you have a problem. Now, this is where different manufacturers do it different, like LMP, like they'll run heat exchangers. It works fairly well. I'm not a fan of it because it gets overly complicated. And I think it's harder for guys to work on it. And if there's an issue, it is a bitch to troubleshoot for most guys. So what they're doing is they're running CDS valves or BLEMOs. I've seen it both ways. And they're basically one opens, one closes, and it forces gas through a heat exchanger or around a heat exchanger. So what they're doing is I've seen it where they take in discharge gas from the medium temp and they're forcing discharge gas to run one way through a heat exchanger and they're forcing the suction gas to run the other way through it. So what they're doing is if the superheat starts getting low, they start forcing more gas through the heat exchanger and less around it. And what it does is it adds superheat to it. And then as it vice versa, as it goes the other way, it could flip it. Now I've seen it do them on the drop leg too. So this is what a lot of the manufacturers have been doing here is lately they've been taking the drop leg and they're running it through the medium temp suction return. So what they're doing is they're using the heat coming down the drop leg. So when it's transcritical and we're running a lot of vapor back and see maybe running 90 degrees back off a drop leg, they're using that to pull some load off the flash tank. So it's helping reduce some load in the flash tank, and at the same time, it's adding heat to the medium temp suction to
Hmm.
superheat a little bit. So the discharge is a little bit more effective, but I mean, it just really depends on the manufacturer and how they're doing it. We'll do it with heat exchangers too. They will take a discharge of the TC medium temp and they run a BLEMO, basically a three-way valve.
Hmm.
So as the suction temp decreases and your superheat starts getting lower, they force more discharge gas through the VM valve and they modulate it through a heat exchanger, which that control strategy modulates that heat exchanger and then it forces it like keeps it like a 10 or 15 degree pressure drop. It
Hmm.
modulates a BLEMO and forces more gas through another side of a heat exchanger to heat up that suction temp. So they're using that to control the suction temp. But that whole control strategy goes back to how to basically control the superheat on the medium temp compressors. The heat exchangers work really well, but there's a lot that could fuck up with them.
Well, that's the thing. So like in the LNP version where they use the two CDS valves and they, like on this rack, the one rack that we saw, it basically has two valves that have to be running in parallel because it's not enough flow even with a CDS 17 on there. And then the same thing for the heat exchanger for the bypass. So those valves basically go together. So if one is running, if the one set of valves is running 50%, the other one's going to run 50%. If the one set of valves is running 90%, the other ones are going to run 10%. So that's basically how they sync up like that.
Yeah, the Carnot method works really well. The only problem is you have a lot of room for failure because if the BLEMO locks up or fails, it slams the discharge of the rack shut.
Oh, because of the three-way valve.
Yes.
Ooh, that's not good. I like the other method. I mean, yeah, it's a little bit more complicated, but at least you have that fail safe in there, right?
The Carnot one's complicated, but the problem is the BLEMOs. I don't know what it is with that discharge one, but like I've probably changed like 10 of them
Really?
in like the last year and a half. What happens is they slam shut and they don't react fast enough and they blow the main reliefs.
Hmm.
Only racks I've ever seen chirp the high pressure reliefs.
You're talking about the 1740s.
Yes,
Gotcha.
because they don't react fast enough and shut down and it slams it shut. That is the most effective way to control superheat on a rack. I mean, I like the intercooler more than how everybody else is doing it. Like that's how it does their instead of liquid injection, they run an intercooler.
Hmm.
So what an intercooler is, if nobody understands, an intercooler at its core is a suction accumulator. Okay, it is a suction accumulator that you purposely keep liquid in the bottom.
Hmm.
So you're constantly boiling it off, and that is what cools down your vapor coming back. So the compressor sucking on it, and then all the vapor coming into it, superheated vapor coming back from the cases, causes the liquid to boil off, and it drops the temp and allows it to boil off and then cool down the suction gas returning. Now you keep a standard level in this intercooler, so like 10 or 15%. And then what you do is you use that liquid that's at the bottom of the intercooler to feed your low temp cases. So that intercooler pressure will be at like 400 pounds.
Hmm.
So instead of your low temp fixtures getting 500 pounds out of the flash tank or 515 out of the flash tank, and
Hmm.
then going down to 200 pounds, now you're taking it from 400 pounds down to 200 pounds. So you have less of a pressure drop. So your valves don't get as oversized. And now you have more subcooled liquid. You
Yeah.
have you have colder liquid. Instead of feeding the fixtures 33-degree liquid, now you're feeding them 20-degree liquid.
Makes
So it allows things to be more efficient. I honestly think that is the best way to handle liquid injection and in overheating issues is to have an intercooler. And then it allows any liquid coming back from the flash tank to drop into the intercooler.
So I want, if you're done with the intercooler, I just want to go back real quick and talk about the hot gas dump because one of the only other things that we didn't discuss was the other reason for having the hot gas dump. Yes, it's primarily because we want to make sure that we're not getting too low of a superheat there. but also on some programming of some of these racks, it will also kick on the hot gas dump in case the load of the medium temp gets too low. So we essentially don't short cycle the rack off and on.
Yeah, the problem with that is it works a little, but most of the time it doesn't because what happens when you have no load?
And your
You got
low temp doesn't work right.
well, when you got no load, you got no load. You can't rob Peter to pay Paul. So most of the time when you're down to that situation, most of the solenoids don't have enough oomph behind them, and then once that happens, your discharge starts dropping off too. So you lose effectiveness.
I wonder if you could. I mean, I don't know how fast this would react, and if I don't know if it would work incredibly well. But like how like most of the controllers, the iPros, the 326s, they all have that heat reclaim set point where it'll basically boost the pressure up on the gas cooler. I'm wondering if you could do something where you could use the heat reclaim set of contacts in conjunction with the hot gas dump, where you could basically just raise whenever we think that we're going to have to use that, we basically turn on the heat reclaim where it wants to run the gas cooler at a higher pressure and then dump more load into there, essentially raising an artificial load.
That doesn't really work, but what does, because here's the problem when you do that, you start holding back more pressure, which reduces the flash tank pressure.
Mhm,
So you start holding back more. Now, what does is I was fucking around one time in the middle of winter
mhm,
at an Aldi rack and I fat fingered the subcooling set point.
mhm,
I lowered it, okay, from like 6 down to like 2.
mhm.
Or no, it was the max receiver pressure. I ended up messing up. And what we did is I accidentally moved the max receiver pressure from 540 to like 580,
Mhm.
which allowed the gas cooler valve, the high pressure valve to open more,
Mhm.
which loaded the flash tank more, which kept the compressor running more. So it essentially false loaded itself.
So you basically, I don't know. Well, how did you had to physically change that by changing it in the controller?
But like, so in the 326, that's a right with Danfoss, that's a writable point on a Danfoss controller.
Yeah.
So you could essentially change that. Like on microthermal, that's a changeable point. So that's so if you had like a two valve controller, you could change that and essentially false load the rack. So what you do is you're opening the high pressure valve more because it has more of a float to basically raise that receiver pressure up.
Mhm.
So you're raising the range of the receiver pressure. So it raises that up. And then at the same time, I fucked with the subcooling number and put it at 2. Well, it's making subcooling really quick and it's opening in the high pressure valve,
Which puts more load on the flash tank.
which more load in the flash tank. And we don't care about anything because like we had no fixture loaded at Aldi. So all the nightshades are down. It's got no load. But what it does have is that flash tank load, which is the major is like a quarter to half the rack load in the wintertime or in the summertime.
Mhm.
So what I did is I essentially loaded this thing. It kept the VFD compressor running at like 60% to like 70%. And the thing hummed all night long. And this thing, it was like -5 out.
I was about to ask you how low the damn with the ambient was.
It ran like a freight train. But manipulating that keeps the load up. Unfortunately, like, the hot gas injection, this only works until it runs out of discharge pressure. The cracks, the solenoids are not big enough. They're running DN2 solenoids. I know, like I've talked to a couple people, we've drilled some of them out to your orifice
Mhm,
and they work better.
mhm.
So it would essentially be a DN4. But the zero zone ones, I think they're running like higher orifice size. They work great, but the problem is once you run out of load, you run out of load. It's you can't just rob Peter to pay Paul because eventually Paul runs out of money.
Paul, you cheap bastard.
Well, like that's the problem with the running liquid injection is that me and James were talking about this the one day. Like they need to open up some of these controllers to be able to have like a switchable point on there to raise the receiver reference up or lower the receiver reference so you could switch it and false load to racks.
Gotcha.
Yeah,
Gotcha.
nightshades and doors are like the enemy to CO2.
Well, yeah, because they like being loaded up all the time.
Yeah, you start lowering the load is when you start having all these issues. Let's talk about
Heat reclaim?
we can talk about heat reclaim. Like it doesn't get really used as much as it should, but let's talk about it.
Well, a lot of one manufacturer that went down in Tennessee, they were utilizing it. So instead of running the heat wreck all the way out to the actual air handler and all the way out to the water, yeah, I know it's not as efficient, but I mean, you get a shit ton of heat off of CO2 anyway, but they're utilizing it to heat up a small glycol loop so they can reduce the amount of CO2 charge. And then basically, from my understanding, what they're doing is they're trying to maintain a differential in order to still maintain that flow via a three-way valve. And was it what the hell? What's the differential set point on that? I can't remember.
I'm not sure, but like my big thing with the glycol to hot gas heat reclaim is we haven't had good luck with the heat exchangers. Like they leak all the time.
Leak how?
CO2, like between the plates.
Like the welded plates?
Yeah.
Really?
Yeah, I've probably changed out like 4 or 5 of them in the last like 4 years.
Yeah, but that's one a year. And then how many stores do you service? I mean, in all reality, that ain't
But like it's
radically horrible.
like I will admit the way it does it with the air to air heat reclaim or
Mhm.
air to hot gas, the fucking dehumidification you get off these damn coils is insane. Because I mean, the discharge temps like you're running is ridiculously high in the summertime. I the benefit of running aired over heat reclaim, I think, is just tenfold. I mean, it's almost a transcritical mitigation. Like as much as people talk about adiabatic and everything else, I think heat reclaims the sleeper one. I
Oh,
mean,
the one that's not used a whole bunch?
well, yeah, you really think about it. If you use it in a dehumidification strategy and you're blowing 50-degree air from a rooftop unit or a DSOA, they're using it to, dehumidify, you're blowing 50-degree air through it. You're now removing a shitload of heat. Like some of the middle of summer, like they could almost bypass the gas cooler, which I don't know
Hmm,
why they don't. Like, so like I was just looking at one the other day. It was 90 degrees outside, running peak full tilt transcritical. This thing goes into heat reclaim mode. The line coming back from the CES unit was 67 degrees.
wow. Hmm. Well, and I don't know, like, so see, I don't remember how I gotta look at the programming, but like, I mean, it would make sense that if you were doing dehumidification, you would only let X amount to control like a discharge air temperature off the coil of like 78 degrees, right? So you're
Well,
not overtaking the air conditioning. And then obviously, if you're going to use it for heat, then you just let it ride.
most of the stuff I've seen, especially like the Aldis, they run like a 20 to 40 pound differential. They're trying to keep it 20 to 40 pound differential, and some of them are running a coil temp. I've seen it 50-50. Some of them run a coil. They have a coil temp sensor in there,
Mhm.
and they're running an actual coil temp.
Gotcha.
And then the DSOA is taking care of cycling the heat reclaim on and off,
Hmm.
whatever it needs to be. But at most of those stores, the heat reclaim coils never shut off. They run basically all day and night long because they're always reheating the store. They're running heating. I mean, which it technically should be. I mean, but it will overtake the store. Like we had one where the actuator failed, and it was running. I mean, it was like 96 degrees by the time we got there.
Mm. Trying to remember if I had a program for the heat wreck so I could see what it was. I don't remember where I have it.
It's a 20 to 40 pound differential.
Heat wreck. Oh, there we go. There we go. Heat wreck differential. Input.
I think the differentials, like running it off of pressure, is like kind of pointless.
Oh, you're saying, oh,
Just let it run until it doesn't need heat reclaim anymore. Then shift the valve back the other way.
gotcha. Well,
I
yeah,
don't like the splitting of the gas going one way and gas going the other way. It ends up messing with the flash tank levels.
really?
Yeah, because end up getting you end up getting liquid stacking in the heat reclaim coil. Because if as you slow the flow down and it starts going the other way, now they don't pump out, so now you got a bunch of liquid sitting in the heat reclaim coil as you slow the flow down.
Yeah.
So that's why I'm not a big fan of doing it that way. And then the glycol stuff, like I said, you lose that efficiency by going there. But I think it's the only way I've seen anybody do water to. So like we'll do glycol to CO2,
Hmm.
then glycol to water. Which I mean, by the time it gets to water, you've lost. You have two different media transfers. So, I mean, you lose some efficiency there.
Yeah, well, yeah, I've seen it at that store I was telling you about in Tennessee. They basically they were doing CO2 to glycol to the water to the thermal stores, and then they had the other ones that were basically just going regular CO2 to glycol, and then running the glycol outside to the, well, not outside, but underneath up above the roof, right, or under the roof, and basically taking that glycol and running it out. But like I said, it can be used for heat reclaim, for regular air heat exchangers. Remember, if you are running that, making sure that any of that piping, if you're running straight CO2 to any of these heat exchangers, it has to be the XHP or the stainless pipe to make sure we don't have an issue, because it'll fillet a regular fitting if one gets put in by accident.
Yeah, I mean, you'll make it on the smaller fittings. We've done that in a pinch. 7/8 and below is usually where before it gets all dicey.
You'd have to make sure that the pressure doesn't surpass that cut where it's the maximum operating pressure. Like, I know there are some manufacturers out there that are using 3/8. I saw my first gas cooler that was copper. I was utterly confused. I'm like, is that HXP copper? He's like, nope. I'm like,
All of ours are like that up here. They're
really?
all this 3/8 copper. I mean,
Hmm.
3 copper, if you look at the burst rating, it's in the thousands of pounds. I mean, the smaller you get, like quarter-inch copper, quarter-inch soft copper has a ridiculous burst rating.
Yeah.
I mean, the smaller you get, the stronger it is. So, I mean, the like 2 and an eighth, everybody would think 2 and an eighth K is going to be like heavy duty. It's not. It's
Mm,
got a really low burst rating because the pipe is so big.
mm.
But yeah, that I mean, the heat reclaims the gist about that. Let's talk about oil, like the big black cloud in the room, the oil system, which has been like the biggest struggle. So it seems to be getting better and better as manufacturers are making it more simple. So
Mhm.
in the beginning, we had the controllers doing all the oil management, which I am totally against because I would rather have oil management done in a self-contained apparatus.
Mhm.
So before you had oil eyes on the compressors and solenoids and oil eyes on the separator and solenoids to drain it. Now we've kind of simplified that. We now have high pressure OMBs, the Kriwan controllers.
OMCs.
Yeah, OMCs, whatever.
Hey, I just want to make sure people know. I don't want people putting an OMB where it might cause issue.
It's always going to be an OMB in my heart. But so you get the high pressure OMCs,
Kevin said I could put it in an OMB.
but you will have OMBs on some of those racks.
Yes, but usually that now they're making it standardized, whether it be a subcritical compressor or a transcritical compressor. They're just keeping with the OMCs, so that
It,
confuses.
no, it really depends.
Yeah, no, you're right.
I mean, it depends where you are. If you're running it, you're gonna have OMCs.
Mm.
It really depends on how your oil setup is done. Now, so like you have these self-contained controllers now. So much easier. Just like we would on a normal scroll rack or something like that, or a recip rack with oil management, OMCs, Crewans, they work the exact same, just higher pressure rating. Now, the old school way of doing it was you had optical eyes, level eyes that were in every compressor in the sides. I've never seen a Copeland with one. I've only seen the Bitzers. I've never seen a Copeland with a optical eye. I don't think they.
No, I haven't either. They usually use they use the eight when they do the one that has the individual solenoids, right? They use those HV sensors, and
Yeah.
I that's one thing that I don't understand. So I was like, because when I, because now they make different versions too, and so like I was like, red means low. No, red doesn't mean low. Red means there's a level. I'm like,
It
but
depends what sensor it is.
I well, that's what I just said. Like there are some that are different.
Manufacturer too, or malfunction too. They a lot they false positive out. So like and to check them, what you have to do is remove them off the compressor, and you have to have an actual like eye and stick it in a cup of oil and pull it out, stick it in, pull it out, and see what if it changes and if it changes the closure. Now that go ahead, Brett.
No, all I was gonna say is like when I was out in Arizona, he asked me to change one out, and I was like, oh well, then I'll change the head because he's like just change the head first. I'm like, oh, okay. So I changed the head, walked away from it, and I was like, yep, it's working, it's working. I checked on the controller, and then came back a couple minutes later. I'm like, what the book? I just changed it, and I was like, nope, nope, it's messed up on the inside there.
There really isn't too much to be messed up. Like most of the time, I see them. It's usually on startup, and they're scratched, or they they got shit inside of them,
Hmm.
like dust. Like what was it the last one I did? We had it kept false positive, kept saying it had oil, and it didn't, and there was a shitload of dust inside of it. As soon as we cleaned it, it was fine.
So before we get into like how those work, I just want to explain the other portion of this. So typically you'll have the oil separator. The oil separator will have the HP sensor on the side there. Once it measures a load on there, it'll kick the solenoid on there. The reservoir solenoid will off of the oil separator will fill. Basically, is usually energized for 10 seconds and then off for 5. So it has a 15-second cycle time. So that's so we can have that level in the reservoir, and to make sure that we have enough pressure to feed both into the compressors on the medium and low temp. Typically you'll have an equalizer line off the top of the reservoir going out into the top of or into the flash tank just to maintain that pressure, because as you have educated me before, typically you need about 75 pounds of pressure to make sure that you have proper oil flow.
Yeah, once you start tiptoeing below 75 pounds, you start getting into the poor feeds, and that is one thing that the OMCs and the Crewans. That's the only drawback is it's gotten a little worse with those. Like they don't like the lower differential. I mean, they're orificed obviously, so they don't handle having the lower differential as much as the other solenoids did. So like the HB solenoids where they were just injecting off of microthermal or CPC doing it, like the OMCs, like they don't handle the low differential pressure as well. So you got to watch that. So that's why you really want to watch that receiver pressure.
Probably because it's ported, right? So, because a lot of those are typically used on high pressure when we're dealing with HFO and HFC systems, right? We can put straight discharge pressure in there.
The high pressure OMCs, like they run straight high pressure OMCs. So they have a high pressure oil separator and they're running straight 1,400 pound oil straight to the compressors.
See, on the Carnot rack that I saw, it had the system that I just explained, where it basically had the separator, then a reservoir, where it knocked it down via that. But I've never seen it without.
That's their industrial rack.
Hmm.
They're what they call their commercial like warehouse rack. What they're doing is it's actually quite simple. They're running a filtered separator, and what they're doing is they're taking that, and it's a reservoir separator combo like
Hmm.
you'd see at a Target
Hmm.
on the Pro Rack, and they've literally run that out with a stainless line, and they pick up the high pressure OMCs off that. So there's straight discharge pressure uh, gas going right to it.
Yeah, I actually I brought it up right now. So the OMCs, the OM5s, the OMCs, the OM5s, they have a maximum operating differential pressure of 1450 psi.
Yeah, so I mean, they take straight discharge gas, and you're going to start seeing that more and more because Westermeyer now has a high pressure centrifugal separator. So they've ditched the filter, which is like my biggest bitch with the CO2
Mhm.
is blowing the temp rights. or blowing the filtered separator, and they have a high pressure centrifugal separator. So I started one up last winter at a Walmart. It
Hmm.
worked phenomenal.
Yeah, you were
So,
saying.
but that's all on high pressure OMCs. Like they're not reducing the oil pressure down. They're running straight discharge gas oil pressure.
So it's basically a CO2 turboshed
Yeah.
without
And
calling it a turboshed because that is a husband trademarked name.
yeah, basically.
Yep.
But yeah, no, it's the only thing I don't like about it is they have high pressure hoses on there.
Uh-huh.
If one of those fucking hoses leaks, holy fuck, the mess. Like oil at 20 pounds makes a huge mess. Oil at 1,400 pounds makes a ginormous mess.
Make sure you don't have any leaks.
Well, I mean, we had a hose blow at a Costco,
Yeah.
and I shit you not, it was 25, 30-foot ceilings in the mechanical room.
Oh my God.
It was dripping from the ceilings. It was all over the drywall. It put a small hole through the drywall everywhere. Like it's probably to this day, a year and a half ago, it's probably still dripping oil from places.
You remember Dumb and Dumber 2?
Oh yeah, where you shit.
There's shit everywhere.
Yeah, yeah. But no, it's yeah. That's basically how they're doing the high pressure OMCs. I would rather have that than anything because all right, now you're eliminating the oil drain solenoid. You're
Mhm.
eliminating the
Reservoir.
the reservoir.
You're
You're eliminating
reducing the load. You're reducing the load off the flash tank because that excessive pressure that you're bleeding off there is going into the flash tank, which is adding more capacity.
the Crewan version of this. You have to program them. Okay. Every manufacturer that has tried to use them, we can't ever get them to not inject fast enough, and they end up filling the compressors too fast. The Emerson ones or the Copeland ones, the OMCs,
Mhm.
never had an issue with them overfilling. Like if they overfill, they're bad. It's a bad one. It just fills all the time.
Something got in there where it actually,
Or they,
damaged it.
but like the Crewan ones, like I don't want to be sitting there trying to program this thing, and every one of them's got to be different, and like it's too much.
Mhm.
Like it needs to be simple. That's the whole point of this. It needs to be simple. I need to be able to grab one of these off the shelf and change it with another one without hooking my phone up to it and trying to reprogram the pulse rates and everything else, and then expect some service guy to come in there afterwards, some apprentice or somebody doing it, and expect them to do the same thing.
Unless there's a procedure. Yeah, no, I get it. I get it. It's making it more simplistic to make it easier for someone to hook it up. Real quick, let's go back. Let's circle back to the system that they really I don't know if it seems like every newer rack that I've seen like kind of ditch the whole the pulse width one, but I just want to cover that in case people have some of these older racks out there that do have them. Typically, the compressor oil solenoids, they have a 60-second cycle time, or at least that, or pulse width time. That's what they're usually programmed for. Usually about what 30 seconds on, 30 seconds off.
It really depends on the manufacturer. I've seen them be 10 sec. I've seen them more of them be 10 seconds on, 10 seconds off. Like I've never seen one at 60. That's usually that's kind of high. Usually they're 10 on, 20 off is what you see most of the time.
Gotcha.
So, but like that system, for example, you're using the controller and you're using the HB sensors.
Mhm.
You're basically so it's looking at say, okay, we got low oil. It's going to make a call, a digital input to the controller. The
Mhm.
logic is going to say, hey, this compressor's low on oil. It's going to say pulse the solenoid on for 10 seconds, and it's going to sit there and it's going to be off for 20 seconds. And if the logic comes back it's still low on oil, it's going to pulse it on for another 10 seconds. It's going to keep doing that. And then like for microthermal, if it goes so long, say it's 2 to 3 minutes, it's however it's programmed, and it's still pulsing at low on oil, it's going to lock out on oil. It's going to say, hey, I've been low on oil for 2 minutes and the oil level's not rising with the pulses. Go ahead and lock it out. And
Yeah.
then go ahead.
No, what I was gonna say is on On the when they do the flexible combiners, usually what was it? There's a I can't talk tonight. Today's just been a stressful day. Max pulse count lockout, where basically if it pulses for 20 times and still not filling, at that point it'll lock out that particular compressor. Is that correct?
Yeah, so it'll have a count how many times it does it and it locks it out. So I mean that's where I see more issues with this with flash tank pressure than I do oil issues because this system is very susceptible to flash tank issues because your oil reservoir is venting to it. And if you lose differential on this system, you end up getting a lot of nuisance oil lockouts.
Oh, so you're talking about, so if your flash tank is not uh,
Stable.
stable, where you instead of having like a 10 or 15 differential, so let's just say your flash tank is 490, right? If it's going all the way up to 500 and then down to 485 or something like that, that's a suitable curve that you should have. But if you start seeing where the
Eh,
BGV is not what.
I don't want to see it more than 3 to 5 pounds.
Okay, but not everyone is you. But what I'm saying is that if you have something like it has a 40 or 45 pound differential, which I have seen, if it goes too low, you start losing that differential. Then in turn, you start losing the differential to help push that oil out because now your reservoir is at a way lower pressure than what it should be. And essentially you're not going to fill up that compressor nearly enough. So you don't get, like you said, end up getting those nuisance trips.
Yeah, I mean, 40 pounds isn't as bad as I've seen it. I've seen him in 90 pounds. I've seen 100-pound swings.
No, the numbers I gave, it was like 20 or 25 pounds, like
Yeah.
basically total. You know what I mean? Like,
Oh, I've seen him go from like 580 down to like 420.
oh, that's not good.
So those are the ones, and that's more common than you think. Those are the ones where these oil issues mess up because say it spikes down to 420, you're running a 400-pound suction. Well, now it's got a 20-pound differential and it can't move the oil. So then it pulses 10 seconds on, 20 seconds off. It calls again, keeps calling. Well, 2 minutes went by. The controller says, well, you're shit out of luck. So you're shut off.
Yeah.
And that's where it kind of becomes a kind of a nuisance thing. Like you'll see higher pulse counts. The only thing nice about that is the controller registers the pulse counts on the compressors a day, and you could see ones that are using more oil. So that is the benefit to that. If they could somehow integrate that on the OMCs and the Crewans, like a pulse counter, like it's closing every time it's calling for oil, that would be killer because that was a good troubleshooting tool.
Yeah, you could have where you'd have to have something that basically closes a set of contacts every single time that oil solenoid feeds, right? So,
Yeah, it's
uh,
one more relay in there. I mean, it didn't seem like it'd be that much.
yeah. So I mean, but as you were saying, I think in the programming, it five 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 580 592 is what I've seen it programmed at. So if it pulses more than that, then it's showing you that you're pulsing it so much, and probably because you're having some sort of issue where you're not able to fill those compressors up nearly
But
as much.
but you also have to watch that because I've seen transcritical compressors in the heat of summer, say like 95 degrees out, 400, 500 pulses a day. They use a shitload of oil when it's transcritical.
Mhm.
So same thing with the separator drains. I mean, Hill was like putting them at like 300 or like 380 pulses a day. Shit,
Mhm.
we were hitting that by noon on some racks.
Damn, son.
But like it's not bad if you're pulsing that much on a separator. It is what it is. Like you're it's good. You're separating oil.
Mhm.
So get the alarm out.
Yeah.
Like I'd rather have an alarm that says it's not separating enough than too much.
So I'm looking at the internals on an OMC right now, and the only terminals I see is ground, L1, L2. You got terminal 5 and 4 for the solenoid, and then you have common, normally closed and normally open, which is on terminals 1, 2, and 3. So you'd have to do something creative with putting some sort of shit like a CSR or something like that.
So what you could do, and I was thinking about this, is you could piggyback off the solenoid coil and drive a relay.
Yeah, but then you'd have to use one of those little itty bitty relays because I think if you were to use a regular run of the mill relay, it might be too many cycles, especially if it's going 500 times a day, right?
Yeah, I
What's
mean,
what's
you could use the SCR.
Yeah, so if you were let's just say you were doing 500 cycles a day times 365. Wow, I can't even use a damn calculator today.
Yeah, I'm burnt out. Like my brain is just fried with that stuff.
It's 182,500 cycles a year if it were to cycle 400 times a day. So that's just one compressor. So they have those little relays. What the hell are those things called?
The little white ones.
Yes.
I mean, so guys, if you are doing these and you're having compressors not feeding oil or you're having high pulse counts, check those relays. Make sure they're actually closing and sending voltage to the solenoids because the the EMS system is closing a relay that's driving another relay
Hmm.
that's driving the power to the solenoids. So check your EMS, make sure EMS is closing and it's driving that pilot relay. Make sure it's actually driving the pilot relay and it's actually doing what it's supposed to. Just because the light comes on doesn't mean the contacts are closed. And make sure you're actually getting good voltage through it and it's not like halfway closed or open. I see that that is a common failure with those things. After a few years, like to be honest, like after like that's a wear item to me. Like every 2 years, those should get changed. You're talking the cost for those relays. Say it costs $200 to change those relays. One service caller paid for.
Yeah, 100%. If not more, if not the plus the lost product that you potentially will prevent from changing those out. It's
Or
the same thing. We go with I when I tell the guys to do PMs, like I'm like change the contactors every year. Just change them every year.
same thing with dryers and oil separator filters. Like they should be changed every year. I don't give a
Every year.
shit. I don't give a shit if it's not plugged. Like what?
Don't let it get to that point.
Yeah,
I mean, I'd rather change it out right before summer than all of a sudden summertime now you're
2 o'clock in the
changing
morning.
20 oil separators in the middle of the heat of freaking summer.
Yeah, and at 2 o'clock in the morning because they never fail at like noon on like a Monday. They always fail at like 2 a.m. on a Friday.
Friday, well, 2 a.m. on a Friday. That'd be Friday. You mean 2 a.m. on Saturday?
Yeah, well, whatever. Same difference. I'm just like burnout and dead inside right now.
Yeah, I hear you. All right. Well, I think we're both smoked. So, man, we'll close this one out, and I guess we'll see you guys next time.